Right, in homework 2 we're asked to find the solution sets of systems of equation using a graphical method. So the idea is here we're going to graph both of these two equations. First we'll need to have an xy axis, so you'll need to draw that along the lines here. Have the arrows at the end just to show that these do go forever, and correctly label them x on the horizontal, y on the vertical. So now these two equations we can write easily with y as the subject, so it's in slope gradient, slope-intercept form. So y equals, we'll subtract x, 2 minus x. So let's start with that. Now because it's just a grid, we'll have to make our own scale, so let's just use the lines to say this value here is 2. And the slope of -1 here means that we'll just be following the diagonals along to the left and to the right. We'll also put arrows on the end to show that this line goes forever, and we usually write the equation to x plus y equals 2. And another convention is to also label the x-axis as well. So let's do this now for the first equation. We'll add y to both sides, and we'll get 5x minus 10, subtracting 10, equal to y. So again, the y-intercept down here at minus 10. So let's see, this is minus 2, minus 4, minus 6, minus 8. So minus 10 is way off the chart. The slope here is 5. So 5, if we go across from minus 10, across 1 would get up to 5 here. Across would go 5 up again. Remember, the positive slope means heading up from left to right. And that pattern continues. 3, 4, 5 up here. And so we can draw that line through those points, like so. Okay, so we can see here the intersection point is this point here, and the coordinates are x first, y second, and you can see that that's the solution set. All right, so let's have a look here. Another way we could write this solution set is to say x equals 2, y equals 0, by the way. All right, so here, let's look at a slightly different method for this question. For this first equation, we could use that same method because the coefficient of y is quite easy to isolate. So we can see this would be minus x minus 3 equal to y. Again, we'll have to draw in our axes. Please skip ahead on the video. There we go, I've gone ahead and done it for you. So minus 3 is down here on the y-axis, minus 3. And slope of -1, because of the coefficient of x here, minus 1, will be going down in this direction. Again, we'll follow the diagonals here, since the scale is 1 and 1. Arrows to show that it continues forever. Something like this. All right, so now let's use a slightly different method for this equation. So you see this a lot. Sometimes people use a little table. So we decide here's the x-intercept and the y-intercept. And so there's special things that we know about the x-intercept and the y-intercept. We know that for the x-intercept, y equals 0. And for the y-intercept, x equals 0. All right, so let's use this information here. Let's start with the x-intercept. If we have y equal to 0, then 2 times 0, well, that will be 0. So you have this equation to solve, 2x equal to minus 4. And I think we can agree here, if 2x equals minus 4, x must be minus 2. So you've got the x-intercept of minus 2 here, and we can pencil that in on the graph. All right, so let's do the same thing for x equal to 0. Let's just erase that. If x equals 0, 2x is equal to 0. So then we'd have 2y equal to minus 4. And again, y equals minus 2. So we can plot that on our grid here like so. Right, so all that's left to do now that we have the x and the y-intercept, we know it's a linear function. And so we can just simply join those two points and continue the pattern along in both directions. And so what we see here is we have some parallel lines. And so remember the intersection is the solution set. And so if there is no intersection, it's the empty set. Another way we could have done this using this equation here, if I just erase this second equation, if we divide everything by, let's say, 2, we could say x plus y equals minus 2. And so here the ratio of the coefficients of x and the coefficients of y are the same. The ratio is minus 1, so that means the lines are parallel. To make this even more obvious, maybe we could have divided by minus 2, in which case you'd have x minus y equal positive 2, and you can compare these very easily. Alright, so that's the second method, using the x and y intercepts. For part C, there's really just a lot of algebra for this one. If we take this second equation and we divide, we notice that the coefficients here, or the numbers, are all multiples of 5. So we could divide each of these by, and to make this, we can see that it's quite similar here. The coefficient of x in the first equation was negative, so if we divide by minus 5 on both sides of this equation, we'd get minus x plus 3y equal to 6. And we should be able to see that these two things are now the same. So when we go to draw this on a graph, we plot our x, y. Now we know that since these are the same, they're going to have infinitely many solutions. But how do we show this graphically? Well, let's just graph, let's say the first one. I'm going to use two different methods here. So let's start with 3y minus x equals 6. And we're going to now, let's use the slope intercept formula here. So 3y, if we add x, we get x plus 6. Divide that by 3, and we'll have a third of x plus 2. Alright, so we want the y-intercept as 2. Can we draw that there? Yep, there's 2. And rise of 1 and a slope, a run of 3. So we're going to be joining these points along here. Whoops. There we go. And also back in the other direction, down 1 and across 3, like so. And that pattern will continue to the edge of the grid, so we can join those points together as neatly as we can. And so we should label the y-intercept, the x-intercept, and here that x-intercept looks like it's going to be 6. Minus 6, I should say. So now for the second graph here, let's maybe do it in red. Let's use our intercept method. So x-intercept when y equals 0. So here we say y is equal to 0. That term doesn't exist. We've got 5x equal to minus 30. And we have x equal minus 6. So there's our x-intercept. The y-intercept, that's when x is equal to 0. So let's erase our working out from earlier. And now if x is 0, this term is 0. So we have minus 15y equal to minus 30. Divide both sides by minus 15 and we get y equal to 2. And we see if we join these 2 points and continue that pattern, we get exactly the same line. So that's how we show on a graph that there are infinitely many solutions. Now, while this x-intercept, this x and y-intercept method might seem quite easy, it's much easier to use the slope-intercept method when we have inequalities. So please keep that in mind.